Birds sit on wires carrying hundreds of thousands of volts and feel absolutely nothing. Most people think their feet are rubbery or somehow insulated against the current, but that isn't the trick at all, and the truth is a lot simpler. The real reason has nothing to do with the bird and everything to do with the path electricity can take. It's the same reason those wires can kill a person without them ever touching the line. But one wrong move changes everything. Crows and pigeons perch on power lines every single morning, and those wires carry enough power to light up a whole neighborhood. But nobody gives it a second thought because the birds look perfectly relaxed. Chances are, you learned a simple answer that sounds right. We assume they don't get shocked because their feet are somehow rubbery, or their feathers act like insulation. But here's the problem. Birds aren't insulated at all, and their bodies have the same conductive material as yours and mine. If a bird completed an electrical circuit, the current would pass straight through it just like it would pass through you. So the real question isn't what makes the bird special. What we need to ask is what's missing from the picture that would turn this harmless perch into a death trap. To see why, we need to look at what electricity actually needs in order to move. It isn't just high voltage that matters. Voltage is only electrical pressure, and the current only flows when there's a difference in pressure between 2 points. It's easy to think high voltage is automatically dangerous, but the danger doesn't come from the number itself. A power line carrying hundreds of thousands of volts is only dangerous if something connects it to a different level of voltage or to the ground. Think of voltage like height on a staircase. When you stand on one step, you don't fall because both of your feet are at the same height. There's no difference, so gravity has nothing to pull you down. The bird is in the exact same position. Both of its feet touch the same wire, so both feet sit at precisely the same electrical height, which means there's no pressure pushing current through its body. Water in a pipe works the same way. If both ends of the pipe are at the same pressure, the water sits still. It only starts moving when one end opens to a lower pressure, and that's exactly what's missing when the bird sits on a single wire. Here's the trick. Electricity is lazy, and it always takes the easiest path it can find. The wire itself is almost a perfect conductor, while the bird's body has real resistance. Think of it like a highway running next to a dirt path. The electricity sees the wire as a smooth road and the bird as a rough trail, so it ignores the bird completely. That leads us to how the system is designed. Engineers know that a single wire is safe to touch as long as nothing else is contacted, so they space the wires far apart to keep animals and objects from accidentally bridging them. So the current stays in the wire where the path is smooth and easy, and it doesn't bother with the bird at all. But everything changes the moment the bird touches something else at a different voltage. That's when the bird becomes part of the circuit. Touching two wires at once is like standing with one foot on two different steps that are far apart, because the height difference pulls you down, and the voltage difference pulls the electricity straight through the bird. That's the only thing that changes the game. If a bird's wingspan is wide enough to bridge two separate wires, the electricity finally finds a route to follow, and the current races straight through it, because the bird forms the bridge between two different electrical pressures. The bird is killed instantly. The same thing happens if the bird touches a grounded tower while sitting on the live wire, because ground sits at 0 voltage, which gives the current a route from high pressure to no pressure, with the bird right in the middle. Metallic balloons cause outages every year for the very same reason, because their conductive coating bridges the gap between two lines, and the result is a flash or an explosion that can plunge whole neighborhoods into darkness. And this brings us to the one place where this danger actually touches everyday life. A human on a metal ladder near a power line is the exact opposite of the bird scenario. The ladder touches the ground, which means the person has one foot in 0 voltage and the other foot reaching toward hundreds of thousands of volts. The setup is a perfect circuit. Between 1992 and 2005, metal ladders contacting overhead power lines killed at least 154 workers. You don't even have to touch the line to be in danger, because electricity can arc through the air if you get too close. Safety experts say to stay at least 10 feet away. So the next time you see a bird on a wire, remember that it isn't defying electricity. The wire is still carrying enough power to run a city, but the bird simply isn't giving the electricity a path to follow. The hidden logic isn't magic. It's just a circuit that never closed. If you want to see more of how the world works, hit subscribe. We take apart the complex world one mechanism at a time.